I'll give you something very briefly on that, and then go on to something a little more exciting.
Very exciting.
Write down this example of 5 plus 3.6. The one and only and simple thing to talk about today with this is when you add and subtract decimals, you're supposed to line them up. But the problem is you can't line up a decimal that's not there. 5 does not have a decimal. But hopefully by the 6th grade level you know where you can put the decimal. Where does the decimal go? You really only have two choices, before or after it. In which case, Victoria, you say?
You put it after that.
Right, and that's the little note to write to yourself. Whole numbers have a decimal after them. Because you're going to need that decimal. You get to put it in there. It ends up being 5 decimal point, and you line everything up with that. 3.6 decimal point. Go ahead and put your 0 over there. 8.6 is what the answer. And that's all I got to say about that.
Wow.
Good. Now a blank piece of paper. We are going to talk about, let's see what I go first. Under exponents, I don't know if we've done, have we done exponents? I don't think we've done them this year. Under exponents, let's say I have this. This little guy up here is the exponent. Oh boy. Go a little better. Which is also called the power. We've got the power. And this number right here is called the base. And what we need to know about this is this. The exponent tells you how many bases get multiplied together. That, ladies and gentlemen, sums up pretty much the whole spiel here. Which means this. Let's go back to my 5 squared. And by the way, when it's a 2, we call that squared. 2's have a special name. An exponent of 2 is called squared. So you would read this as 5 squared. And it probably refers back to finding the area of a square. Because when you find the area, now please understand this. This 2 tells you that you have 2 of those 5 multiplied together. And 5 times 5 is not 10, it is 25. 3 squared is not 6, it is 3 times 3, which is 9. 7 squared is not 14, it's 7 times 7, which is 49. 10 squared is not 20, it's 10 times 10, 100. Got that? Welcome to the world of exponents. Victoria.
Well, what would you call it if it like told you to write it out in words? What would you call it if it was like a 3?
Well, we're getting to that. It's cubed. 3 is an exponent of 3 is called cubed, but that doesn't come up in this chapter, so I wasn't going to go there today. Okay. So they'll give you problems that look like this, ladies and gentlemen. They'll say do this addition problem, 4 squared plus 3 squared. Okay. You have to do the squared parts first. If you look at our order of operations there, exponents come before adding and subtracting, so you have to do that first. And you'd write this down on your paper just like it is, and then you'd go, oh, 4 squared is 4 times 4 is 16, 3 squared is 3 times 3, which is 9, and 16 plus 9 is 25. And everybody's happy.
Yay!
Which, unfortunately, is not the end of our note-taking. One more blank piece of paper.
Mr. Mom, do we have to write for squares? Do we have to write the problem out like 4 times 4 is 16?
No, you can do 4 squares. You don't have to write 4 times 4. So who? Same thing if it was subtracting. Now this one, and I'm sure they put this up there, this one we talk about what's called roots. And specifically today they're talking about square roots. Square roots. And the square root symbol looks like this. It's not a division sign. The division sign doesn't have this little heart on this thing over here. This does. Okay? And when you see this, you say it like you're looking for the square root of 25. This little sign right here is called the radical sign, because it's radical. And underneath the sign there, just for your information, is called the Radicand. Someday we'll put a number up there which is called the index number, but right now we're not. And square roots are like the opposite of squares. The question a square root asks you is, what number times itself gives you the radicand? This is what the problem asks you. So the square root of 25 asks you what number times itself. It has to be the same number. Multiplied together will give you 25. And the answer to that is 5. The square root of 25 is just 1 5. You don't put 2 5s down. And unfortunately, 6th grade, there are not a lot of these that work out nicely. Okay? I'll give you the ones that do. You can have a square root of 1. The square root of 1 is what number times itself gives you 1? 1. You can have a square root of 4. What number times itself gives you 4? 2. You can have the square root of 9, which is 3. And the square root of 16, which is 4. And the square root of 25, which is 5. Those are all nice square roots. Any square roots that fall between them, for example, the square root of 17, we don't particularly like. We can get pretty close to it, but for right now, you're not going to deal with that. Just know that there are only certain ones that work out, and those are the perfect squares. We call them the perfect ones. If they work out, we call them perfect. And just because you're smart, this number here, when you have a square root of 1 that doesn't work out, we call those irrational numbers. Irrational. They just don't make sense to us. They're irrational. Isn't that probably the most exciting thing you've ever had?
Yeah.
That, children, should get you